Pressure of oxygen is higher in the alveolus. Where is it lower? Huh? In the deoxygenated blood, which is in the capillaries. So compared to the partial pressure of oxygen in the capillaries that is surrounding the alveoli, the partial pressure of oxygen is in the alveolus is higher. So now what do we have? We have a gradient for the movement of oxygen. Oxygen will move from alveolus to the capillary. That's all. Simple logic. So in the designing of this structure, we have to create a format. We have to create a structure which will bring us to a situation where there is a possibility of gas exchange. Correct? If you create partial pressure, all of that is there, but you don't have a situation where exchange can happen. And what is the point? You have produced wonderful goods. You have produced very good products. You have produced very good products, but you don't have a mechanism by which people can buy it. How will you have business? Where is our business lady? Huh? Where is she? Ah, here only. Okay. Alright, you have produced so many goods and you don't have a front to sell it. You don't have a place where people can buy it. What is the point? Like that, you have partial pressures can be created. Partial pressures are there. In the blood, oxygen has been utilized, carbon dioxide has been loaded. Atmosphere has oxygen and carbon dioxide. So exchange can happen, but where? You have to create a place where exchange can happen. That is the lungs. Okay? And lungs, you have created all a network of branching tubes. How do you make the air enter into the lungs? For that you have created these pipes coming up to the nostrils. That is taken care of now. We have designed it in a way that air can be delivered to the lungs and air can come out of the lungs. So there is continuity. You have created a continuity between the atmosphere and the membrane across which gas exchange can happen. Which is the membrane across which gas exchange can happen? The membrane is the membrane of the alveolus, around which if this is one alveolus, we have a capillary around here. So very closely attached. So what do we see here? Alveolus has one layer of squamous epithelium. The capillary that is going around the alveolus also has one layer of squamous epithelium. So this is a thin membrane. This is the respiratory membrane across which gas exchange can happen. Oxygen goes here, carbon dioxide comes here. That's all. This design is clear for you. You have to understand how big this network is. How big the network of tubes are. How many alveoli might be there in one lung? How many alveoli may be there in each lung? Up to the terminal bronchiole, you can assume, it is estimated that there are 10 to the power 23 branching. 23, it branches 23 times, not 10 to the power 23. There are 23 levels of branching. Every time, see, whenever there is branching, what is sure is each one is becoming at least 2. Correct? When you say branching is happening, we can be sure that at least 2 branches are forming. Then there is no, otherwise there is no branching. But should we say that only 2 branching will happen? There can be more also. Even if we assume that there are only 2 levels of branching, it happens 23 times. So how many terminal bronchioles will you have? 2 power 23. 2 to the power 10 is 1024. So 2 to the power 23 is 2 power 10 into 2 power 10 into 2 power 3. 1024 into 1024 into 8. We will round it off. 1024 we will make it 1000. 1000 into 1000 into 8. 1000 is 10 to the power 3. 10 to the power 3 into 10 to the power 3 is 10 to the power 6, a million. 1 million is 10 lakhs. into 8, 2 to the power 3 is 8. We have 8 million terminal bronchioles. We have 8 million terminal bronchioles. Respiratory bronchiole, alveolar duct, alveoli. Each terminal bronchiole will give rise to 2 respiratory bronchioles, let us assume. 8 into 2, 16 million. 16 million respiratory bronchioles. Each respiratory bronchiole will give rise to 2 to 3 alveolar ducts. Let us consider 2. 32 million alveolar ducts. Each alveolar duct will give rise to 6 to 8 alveoli. Let us consider 6. 32 million into 6, 180 plus 12, 180 plus 12, 192. About 200 million alveoli in each lungs. 200 million is 20 crore alveoli in each lungs. Alright, 1 million is 10 lakhs, 10 million is 1 crore, 200 million is 200 divided by 10, 20 crore. Each lung has got about 20 crore alveoli. What might be its size? That is why you see it like a sponge. What is sponge? Sponge is something with multiple pores in it, small pores in it. If you have 20 million small compartments in this, it is like a sponge. That is why it is like a sponge. That is why when you watch movies, they put the advertisement, no? Tar. Okay? सिगरेट पीने से आपके फेफड़े में तार बन जाता है, इतना बड़ा तार. Alright, can accumulate. It's like sponge. It will hold. So keeping the lungs healthy is important. You are doing your bit for that. Alright, imagine metabolism is dependent on the availability of oxygen. To make oxygen available, you have to keep your lungs healthy. To keep your lungs healthy, what do you do in the morning every day? Pranayama, breathing exercises. Alright, see again, design. Alright, everything, purpose, design, action. Purpose, design, action is so powerful, not only for designing the lungs. What is the purpose of all of you coming here? The purpose of all of you leaving your families, taking a year's break, risking some disgrace also. Some people, as you are here, might be laughing at your attempt. People who don't trust in you, people who don't believe you, people who want you to fail. There will be no. If I ask you, do you know somebody who don't believe that you will make it? Do you know somebody who don't believe you will make it? You have people around you in your known circles who would have expressly told, or you know that they believe that you can't do it. Some of them might have told it also like concern. It's not possible, it is very difficult, there is so much competition, why do you do it? At least join BSc, at least join some course. You will not be wasting 1 year. How many of you heard this kind of talk? Okay, others have not heard it, so you have a lot of supportive people around. Right? Do you know people who want you to fail? Do you know people you know that they don't like you succeed? There are people like that also. Don't you have doubts about whether you will be able to do it or not? Don't you have doubts about it? Has the thought never occurred that if I am not able to clear it, then this year would go waste, 1 year. You will be behind. Your friends will be in some other course, second year. Those of you who have taken more than 1 year break. There are some of you who have taken this might be your third year of break. So by the time you finish this effort, and if it doesn't click, if it doesn't work, then you are entering into graduation. Your friends who were with you in school would be completing their graduation. So you have taken the risk of pulling your life back by a few years. Correct? But why? You have a purpose. You have a purpose. The purpose is you have a dream. To fulfill the dream is the purpose, the dream of becoming doctors. Whatever the reason you want to become doctors, that is your reason, no problem. You might have got some motivation from somebody, you are inspired by somebody, you feel this is helpful, it will make your family better, it will position you at a different level in the society. Your status improves, your financial condition improves, your social positioning improves, at the sacrifice of your personal comfort. So those who want to become doctors have to decide to give up on having comfort on a day-to-day basis. A doctor's life is a difficult life. It's a tough life. You have to be, it's a life of dedication, it's a life of sacrifice. You sacrifice your comforts for the welfare of others. So it's a meaningful life. With all that, you are here. Purpose is clear. You want to become doctors. Doesn't just become like that. No, if you just keep jumping on the terrace every morning that I'll become doctor, doesn't work that way. There should be a design. Design to make sure action happens in the right way. So the routine that I have given you, the activities that I am training you on, the way you have been told to practice, how to make notes, what kind of notes to make, how to go about solving the papers, making you sit from 145 to 520 during the test, not allowing you to get out during that time. Every small bit of action that has been designed for you is designed to help you achieve the purpose. Now design is there, lungs is there. Nature has designed lungs for us to have proper ventilation and proper gas exchange and supply the body with oxygen. Body is supplied with oxygen, body will perform optimally. An optimally performing body is healthy. A healthy body is more likely to be ready to do higher tasks of achievement, higher tasks which might lead to achievement. But if you start smoking, the design is there. Action will not let the design manifest into results. Everything is therefore so very important, extremely important. Alright. So purpose, design, action, always keep thinking about it. When your alarm rings and you are feeling like sleeping. Now I am monitoring it closely. If a senior teacher, chemistry teacher is 60 plus, is close to 60 years of age, he might not be able to come and monitor you at 5:15 in the morning. So is that reason enough? Is that reason for you to not do? No. All right. You're all people who are old enough to be responsible. So you have to be responsible and make sure everything that is designed goes on properly, perfectly. So purpose everybody will have. Whether it is strong or weak, whether it is fantasy or dream, that is different story. But everybody will have some purpose. The problem comes in not having a design. A design. Now if we, would you trust God to design the body or would you trust doctors to design the body? God to design the body, no? The more and more insight somebody has into all aspects of the transformation of vision into reality, the more efficient will be the design, the more complex and comprehensive will be the design. For you, it will just look like a routine. Every element in that has been designed with a specific purpose, coming from the insight of having seen it end to end, through and through. All aspects, those dimensions which you cannot even know exist, are being considered to design a program for you. What is in your control? Purpose is complex, it has come into your mind, you cannot do anything about it, it's already there in your mind. Design I have given you. What is in your control? Action. That's all. Purpose, nature has fixed it. Survival is the purpose for all the systems. For all the systems to evolve, survival is the purpose. Design, nature has evolved it. Nature has evolved design over millions of years. The design of your respiratory system has not come in a day, no? It has not come in a few years, or it has not come from your grandfather. It has come through millions of years of evolution. What is in your control? Action. purpose of life is not in your control. Design is already there. Take care of actions, you will have optimum performance. Optimum performance will lead to higher success. That's all. Alright, lung design. Now there is a problem with the ventilation, lungs. It is an open system. Open system meaning what? It is in continuity with the atmosphere. The lungs is in continuity with the atmosphere. We have all the tubes, air can get in, exchange can happen. Exchange membrane is also ready. Blood vessels are also designed in a way that capillaries come and touch the alveoli. Alveoli is surrounded by capillaries, all of that is there. If air can enter into the lungs, gas exchange can happen at the membrane. How can air enter the lungs? Now air is going in, it is in equilibrium with the atmosphere. Correct? No, it's a mechanical system. It is in equilibrium with the atmosphere. There is a room that has been created, door is open. Room is created, door is open. So air enters. Problem is, how do you make sure air gets out? How can you put it out? Or if you want more air, how do you expand this room? You have to design something to make this room expand and contract. Expand to allow more air to come into the room. Contract to remove air. If you don't remove air that is there in the lungs, how do you remove the carbon dioxide? And when we say remove air in the lungs, is it completely creating vacuum within the lungs? No. You are removing a significant part of the air that is present in the lungs, taking in fresh air. There is already there air, the air will always remain there. That is called residual volume. When we talk about lung volumes, residual volume is the volume of air that will be present in the lungs even after a forceful expiration. How much is that residual volume? About 500 ml. About 500 ml is the residual volume. How much do we inhale in a normal respiration? What do we call that volume that you inhale during a normal inhalation? Tidal volume. Tidal volume is also around 500 ml. So 500 ml of air is always remaining within the lungs. You cannot squeeze it out. Because it's a sponge. You cannot just, if you want to squeeze it out, you have to make it a sheet. Alright. And 500 ml you take it. So that mixture is what creates the partial pressure. Alright. How do we make this a dynamic movement oriented system? Let us say this room is the thoracic cavity, the thoracic cavity or the cage, rib cage. You are the lungs, or there is a big balloon which is the lung. The balloon is connected to outside. The balloon is connected to outside. The room is closed. The room is not connected to the outside. Room is closed, but balloon has connection to the outside. Now you have to make the balloon suck in air or squeeze out air. How do you do it? The balloon has to suck in air. When you inhale, your lungs is sucking in air. It is not coming in just directly. When somebody dies, when there is death, there is no respiratory movement. Does that mean there is no air in the lungs? Will there not be air in the lungs when a person dies? There will be air in the lungs, but the air in the lungs will be in equilibrium with the air in the atmosphere. When we are living, how do we suck in air? How can we do this? How does this balloon expand and contract? It is in continuity with the outside. The room is not in continuity with the outside. On one end you have all these bones and fascia covering, on the lower end you have diaphragm, all around you have the rib cage, muscles, fascia, all of that covers, and the thoracic cavity becomes closed compartment. Alright. So like this is the cavity, this is the balloon. Now how do you make it expand and contract? Problem. Next design problem we have to take care. Though this room is closed room, the room can also expand and contract. The rib cage can move, no? The diaphragm can go down, rib cage can move up and out and in and down. But how can you translate or how can you transfer the movement of the room to the movement of the balloon? If I pull the balloon, if I increase the volume of the balloon, what will happen to pressure inside the balloon? It will decrease. So if I increase the volume of the balloon, the pressure inside will decrease. Compared to the atmosphere, there is a negative pressure. So air moves towards the region of negative pressure or lower pressure. Air moves from higher pressure to lower pressure. So if I have to bring about exit of air from the balloon, what should I create? High pressure inside the balloon. Can I create pressure directly? How do I create high pressure? I will decrease the volume. I will squeeze the balloon, the volume decreases, that increases the pressure, exhalation happens. Now to bring about inhalation and exhalation, I have to create a negative pressure within the lungs to make inhalation possible. I have to create positive pressure within the lungs to make exhalation possible. Now this negative pressure and positive pressure is in relation to the atmosphere. It's in relation to the atmosphere. Alright. How do we do it? We have a rib cage, we have the thoracic cavity which can move. We have lungs placed inside it. Lungs can also expand and contract. But you cannot touch the lungs. Lungs does not have any muscles attached to it. You have to find a way to make the movement of the thoracic cavity transfer to the lungs. How do you make it? How do you make the movement of the thoracic cavity transfer to the lung so that the lung follows the movement of the thorax? That is what happens, no? When we inhale, the ribs go outwards and upwards like a bucket handle. This movement is called bucket handle movement. Alright. And when we exhale, the ribs go downwards and inwards. Bucket handle goes like this, no? Rib movement is like this, it is not like this. The rib cage movement is like this, goes outwards and upwards, downwards and inwards, outwards and upwards, downwards and inwards, like a bucket handle movement. The upper part of the ribs move in a different way. It goes like this. If you observe, upper part of the ribs move like this, inhalation. This part of the ribs. This is bucket handle, this is pump handle. Pump. So two types of movements of the rib cage. And diaphragm moves like dome to flat, dome to flat, dome to sheet, dome to sheet. When you inhale, the diaphragm becomes like a sheet. When you exhale, the diaphragm becomes like a dome. So when you inhale, the rib cage is moving outwards and upwards, increasing the space within the cavity. The diaphragm, which is a dome, becomes flat. So increases the room inside the thoracic cavity. But how can this increase in volume of the thoracic cavity be transferred to the lungs so that the lung also gets stretched? What makes it possible? How can we do it? Come on. What is lungs surrounded by? What is around the lungs? What do we have? Pleural membrane. How many layers? How many layers of pleural membrane the lungs has? 2 layers. There is a membrane around the lungs, pleural membrane, it is 2 layers. What is in between the 2 layers? Fluid, pleural fluid. Now, one layer of the pleural membrane is attached to the lungs, another layer of the pleural membrane is attached to the inside of the thoracic cavity. In between there is fluid. So when the thoracic cavity expands, what will it pull? It will pull the outer layer of the pleural membrane. What will that pull? That will pull the fluid. What will that pull? That will pull the inner layer of the pleural membrane. What will that pull? that will pull the lungs. So pleural membrane, the pleura is designed to make this possible. Why do we have pleura? Pleura is to make lungs and thoracic cavity get connected to each other so that the expansion and contraction of the thoracic cavity can be transferred to the lungs, making it possible for the lungs to expand and contract, thereby facilitating ventilation. That's all. No? So how do you make these bones move? You have muscles attached to the bones. What are these bones? Ribs. Ribs are also referred to as costa. Costa. Muscles that are in between the ribs, what can you call that? What are the muscles which are in between the ribs? What are those muscles? Intercostal muscles. Costa is ribs. Inter is between. Intercostal is an adjective referring to something in between the ribs. What is between the ribs? Then comes the noun muscle. Alright. Muscle is the reference there. There is a muscle. Intercosta between the ribs becomes an adjective, reference to its position. Correct? So, the reference to the muscle between the ribs is intercostal muscles. That's all. Clear? So, the design of this is done. Now, gas exchange happens through partial pressure gradient. Gas exchange happens through partial pressure gradient, and this partial pressure gradient makes it possible for the oxygen to enter the lungs, enter the capillaries, and carbon dioxide to move out of the capillaries into the lungs. Partial pressure, how much is the partial pressure? All of that we'll see. 100, 40, 40, 46. At different levels, arterial blood will have different partial pressure, a little higher of oxygen and little lower of carbon dioxide. Venous blood will have different kind of partial pressure. At different organs, we will have slight varying partial pressures. So for simple understanding purpose, consider oxygenated blood will have 100 millimeter mercury partial pressure of oxygen, 40 millimeter mercury partial pressure of carbon dioxide. Deoxygenated blood will have 40 millimeter mercury partial pressure of oxygen and 46 millimeter mercury partial pressure of carbon dioxide. That's all. Alright. So remember these only, 100, 40, 46. 140 for oxygen, 40, 46 for carbon dioxide. So here, what will be the partial pressure of oxygen and carbon dioxide in the inhaled air? It will be slightly higher. 140, 40, 46 is in blood. Alright. Here you will have about 125 millimeter mercury of oxygen partial pressure. Carbon dioxide will be lesser, 40. Now, higher partial pressure, oxygen enters. What will be the partial pressure of oxygen in the oxygenated blood now? About 100. Then carbon dioxide here, what would be carbon dioxide here? Before exchange, 46. After exchange, here it would become 40. So it goes round. At the level of tissue, when the oxygenated blood reaches the level of tissue, partial pressure of oxygen in the tissue would be around 40. In the arterial capillary would be 46. From arterial capillary, oxygen gets in to the tissue. What will be carbon dioxide at the level of tissue? 46. It would be 40 in the arterial capillary. So carbon dioxide comes out of the tissue. So as the blood continues, in the venous blood, partial pressure of oxygen would have become 40. Partial pressure of carbon dioxide would have become 46. That's all. Goes on. The cycle continues. That comes to the right side of the heart, right atrium, right ventricle, goes back to the lungs, picks it up, goes. Mechanisms initiated to take you away from danger. If you cannot go away from danger, there should be mechanisms to deal with danger. Correct? So what would be your first response? You are walking on the street, you are walking on the street, you are going from a function or a party, you have some ornaments on you, you have some valuables with you, you see there are some people, 2 or 3 people looking at you, you sense that they might be interested in the ornaments. What is your first response? What will you try to do in the first? You look at them, how dare you? You will go towards them and ask them, what is your problem? Will you do that? Will you do that? What do? You will try to gather pace. You will try to gather pace to reach a place where there are more people and you might feel safer as quickly as possible before they catch up with you. You are gathering pace, they are also gathering pace. Those 2 fellows are also coming at a higher pace towards you. Now they are close. What will you do now? Then confront. What? You are afraid. But will you show that? Will you say, what? No, you will try to put up a brave face. What? What do you want? Don't mess with me. I am dangerous. Alright? But your face is giving that expression, your voice is coming out in a different way, but your heart is barely going inside, it is beating in your mouth. Correct? But this is all designed to ensure that you survive, overcome danger. Internal dangers, I told you, I gave you example of glucose. So how do we get information? See, there is information gathering devices. Consider this as a feedback mechanism. Considering this as a communication system, the nervous system as a communication system where there is information gathering devices. Gathered information has to be transported or transferred to the processor. There are multiple levels of processor. Everything need not happen in the same central processor. So information gathered needs to be transferred to the appropriate processors dedicated for specific functions. From their control room, the central control room should be notified. A response has to be designed, response has to be communicated, and the response has to be acted upon by all those parts that need to participate in the response. Correct? If we consider this situation where somebody is trying to steal from us, or somebody is trying to rob us or harm us, whatever. Information gathering device. You see visual cue, sending a message that somebody is there. Wherever it goes, let us see. Then auditory cues, sound of the movement, cue from the surroundings. It is dark. You look around, there is nobody around. Isolated, dark, isolated, new moon day. You don't even know whether they are people. Alright. It depends where you are coming from. If you are coming from watching a late night horror movie, they might appear different. So cues are there. Danger is communicated. First is gathering information, communication of information to the processor. The processor quickly processes information and tells and sends message that escape. To escape, blood flow is redirected to the limbs. Blood flow is redirected to the limbs. Message is sent to the adrenal glands to produce more adrenaline, so that intensity of action is initiated. Alright? Movement. You move faster. And when the confrontation happens, further movement, further blood flow, further messaging to the, initially it will be messaging to the limbs to walk faster. When the person is closer and you have to confront and you have to fight back, the messaging is to the rest of the body, to your hands, to your legs, to your body for balance. All of this is a coordinated effort now. And controlled messaging to different parts of the body. It should not be like there is a message being sent to the left hand to punch on the right side of the face of the person. You are kicking your leg backwards. That doesn't happen, no? So think of the complexity. Think of the complexity of information gathering, compilation of information, processing of information, designing a response, delivering message to various parts of the body to bring about a response. There are 206 bones, around 680 muscles in the body. Alright? A simple walking requires coordination between so many muscle groups, and it is happening so precisely. It doesn't happen like a robot, it doesn't appear like a robot is walking. It's very smooth, continuous and free. So there is a free flow, there is a grace to it. This kind of action is to be taken care of by the nervous system. Alright? Now how do we design? This is the purpose. We understood the purpose. How do you design? How do you design? You need to have information gathering systems. So we can call them sensors in the physical world, but in biological world we call them receptors. Receptors are the sensors which are trained to identify specific set of inputs. There are receptors in the eye which can sense light. There are receptors in the ears, in the auditory apparatus, which can sense waves. Wavy motion, so interpreting sound. There are receptors on your skin which can sense touch, temperature, pressure, pain, all vibration. All of these receptors are given on the skin. The skin has all of these receptors: touch, pressure, pain, temperature and pain and vibration. So you need to know, no? We are sitting in this room. If there is an earthquake happening, how would we know? Slight vibrations in the ground. If your house is near a railway track, you will get used to the vibration. You will learn to ignore it. But somebody who comes first time to your house, they will be able to sense those vibrations and they'll ask you what is happening. They will say, nothing, it's just a train person. Alright? So these receptors on the skin. Externally, to sense the external danger, you have the sense organs equipped with a large number of receptors or the sensors that can gather information from the surroundings. So the purpose of the sense organs is to gather information from the surroundings. The eyes are not designed to study. The eyes are designed to look for dangers around. But we are using it to use our brain to create complications for our life. Alright? That's all, no? If you look at it, how simple a dog's life is. I just wake up in the morning, do some stretching exercises, go around, talk to friends, go eat something, sleep. That's all. If somebody from some outsider comes, have a nice duel, fight, die. That is what we are also doing, but in a much more complicated way. That's all. That's all, no? A dog can sleep anywhere. We first work hard, go through a lot of sacrifices, give up on day-to-day life, then do more sacrifices to go and work for somebody, make money for them, get some money from them, then go and get a bed, and then don't sleep on it because you want something else. Alright? Constant efforts to get things which you will not use because you want something else. Constantly trying to get something else. I have an explanation for why we have so much aspirations. I have an explanation for that. That relates to nervous system. So I will tell that here. I am writing a book on that. Why are humans not satisfied? Have you experienced this from your childhood? There will be multiple times when you thought, if I get this, I will be happy. Right? Initially, maybe when you started going to school, you would have thought, all that I need in life is a cycle. If I get a bicycle, I am happy. I don't need anything else. You would have told your parents, no, you get me this, I don't want anything else. Parents will tell you, you have to take care of it. You will get a new cycle. The first 2 days, you will not let anybody touch it. You are dirtying my cycle. Next few days, you are cleaning it every alternate days, once in a few days. After that, you don't know where the mud ends and where the cycle begins. Cycle blends into the background dust. Right? Why did you lose interest on the cycle? After the cycle, you wanted something very badly, you got it. Until you got it, you had that intense craving for it. But after you got it, within a few days, the craving goes down and you develop that high intensity craving for something else. At every stage of life, you will have something that you are craving for. You want it very badly until you get it. After you get it, you lose interest on that gradually. Then you want something else. Why is this happening? So if you notice, entire lifetime of people would have passed. They would have gathered so many things, but they would not have enjoyed anything, because throughout their life they would be wanting something more, something else at every point of time. A dog has no such problems. Happy. All that it wants is food, rest, some entertainment. Over. Why do we have these kind of cravings? When does perception develop in human beings? When does perception develop in human beings? When are we able to notice our surroundings? After we are born? Is it? Brain development, nervous system development begins at 12 weeks, intrauterine life. That is at about third month, at the end of third month, nervous system development begins. By 5 months, see, the mother experiences the kick of the baby, movement of the baby at around 5 months. That means nervous system is working, muscular activity is working. Sensors or the receptor development begins much earlier than that. Muscular action is a higher function in evolution compared to sensors, receptors. So receptors are developed between 3 to 5 months of intrauterine life. Inside the womb of your mother, you have experience of the surroundings. You have an experience of surroundings. And what is mind? Mind is an aggregate of all your experiences, with the ability to mix and match the experiences to create new experiences. But the basis for all the new experiences is your past experience. Whatever you have experienced, mix and match it and you create something new. Nothing new. It is like creating new words in the language. The basis for the entire English language is 26 alphabets, no? How many millions of books have been published? Billions of pages of content. But all of that has 26 alphabets only. Mind is like that. Imagine we have thousands and lakhs of millions of unique experiences. And imagine the kind of literature it can create by mix and match. With 26 alphabets, there are billions of pages of literature created. With millions of experiences, what can mind create? Alright. So, the earliest experience, when it was a clean slate, when there was no mind, the earliest experience of everything was what was in the womb. There is no heat or cold. It is an AC environment. Temperature controlled. Correct? There is no pain inside the womb of the mother. You don't even have to eat. There is no hunger. There is no thirst. The closest experience to what you can call bliss, the reference to what you call bliss, is what you experienced in the womb of your mother. That is the experience of bliss, which acts as the basis of our reference. What do you compare with? When you eat something, whenever you eat something, whether you like it or not is dependent on how well it is comparing with your reference. What is the reference that you have? The reference that you have for comparing taste of food is the taste of your mother cooked food. Whatever food your mother has cooked, what you have been used to, that is the reference to compare it with something else. So if the food that you eat compares with this reference, the more it closely compares with it, the more you like it, the more good it is. What you love to eat, somebody might hate to eat because the references are different. But common reference for all of us is the experience of bliss that a child experienced in the womb of its mother. When the child is born, the initial experiences is the contrast between what it experienced in the womb of the mother and what is outside. So the child has to breathe now. The first breath causes expansion of the lungs, which is painful. The child cries. Within a few minutes, the child is experiencing cold, it is shivering. It is experiencing cold, discomfort. Within a few more minutes, the child is experiencing an internal discomfort, hunger. You see that? The initial few months of the child until its intellect starts developing with lot of social interactions and more references start coming in, the initial few months of the child is a cry to go back to its home. It wants to get back home. Alright? The child wants to get back to its home, the home where it experienced bliss, womb of the mother. As more and more people interact, more and more experiences come, the mind starts developing more interpretations start developing. So within a couple of months to few years, by the end of 1 year, the child would have slowly started to lose the touch with what it was inside. The experience remains. It goes from conscious craving to get back to the womb of the mother to the subconscious undercurrent of what is required. So it goes down and down and down, deeper and deeper in your mind. So deep in your mind, the reference keeps getting pushed. It's like you are accumulating more and more references in your mind, in more and more experiences in your mind. The older ones are getting pushed deeper into the mind. The deepest layer of your mind has the reference of bliss. That is what you are comparing everything with. When you say, I want this will make me happy. You want to experience the same feeling that you experienced in the womb of your mother. When you get it, there is happiness. But your mind will tell you from deep inside, not this, not this, not this, not this, not this, not this, not this. Anything that you give from external material sources will not match with the experience that you had internally. So what you do in the morning, the meditation routine, reflection, prayer and all that, that will clear the barriers in your mind for you to go deeper into the mind where you can touch consciously the experience that you had in the womb of your mother. So only by going more and more internal, deeper into your own mind, you will reach the stage of experiencing the same bliss that you experienced in the womb of your mother. Nothing that you want, that you crave for, can give you the happiness to match your reference. You understand that? So why are we aspirational? Why are we ambitious? Why do we want more and more and more and more? All of us are trying to get back into our mother's womb. It is not possible physically. So where is the mother's womb? It is deep down inside us. We have to go internally, mentally. Alright. See, all of this is going on in the nervous system only. Nervous system is responsible for creating cravings in your mind. So first level is survival. Sensors, we understood. Now, once the sensors receive information, they have to pass it on to the processors. The transportation wires which will carry the signals of input and which will also bring the output signals are called nerves. Nerves. The entire nervous system is made up of one type of cell. What is the cell that makes up the entire nervous system? The basis of the entire nervous system? Neuron. Modification of the same neuron to suit different functions is what we find in the entire nervous system. So nervous system is made up of neurons, which are the functional cells, and there are support cells. Cells which will support. Packaging cells are there. Fat cells are there which will provide cushioning and insulation. But functional component of the nervous system are neurons. Is that clear? Neurons also have these three parts. there is cyton or the cell body, which is the processor, dendrites, which are the receivers, axons, which are the transmitters. Alright. You have neurons, you have the neuron cell bodies only in the central nervous system. Cell bodies or the processors are present only in the brain and spinal cord. That means throughout the body, what is being spread out? The receiving wires or the transmitting wires, dendrons and axons. Length can be as long as it is required to reach where it is supposed to reach. You understand? So you can have very long dendrons, very long axons. Cell bodies are present only in the central nervous system. So you can divide it into processors and distribution network, processing and distribution network. The processing unit of the nervous system can be called as central nervous system. The distributing network can be called peripheral nervous system. So peripheral nervous system is made up of nerves. What are nerves? Nerves are bundles of these axons or dendrons or both. You bundle up a lot of axons and package it. That is a nerve. It's like wires. There are multiple wires. You can bundle up wires into this pipe can have multiple wires. You can consider each wire to be an axon. Wires can be. Is it necessary that all the wires are going from the same place to the same place? You can have a distribution network. So there are nerves, receivers, nerves to carry information, processors. First information goes to the spinal cord, from there it goes to the brain. Then reverse also to the periphery. So the pathway by which information is carried from the periphery to the center is called afferent pathway. Afferent means towards, bringing it closer to. Then the pathway which goes away from the processor to the periphery is called efferent pathway. So you have afferent neurons, efferent nerves, efferent nerves. Alright, understanding? Get the design properly. Then function we will discuss in the next session when we meet. Clear? And in all this, we also discussed about two types of functions: voluntary functions and involuntary functions. Voluntary functions and involuntary functions both are mediated by nerves only. Processing is happening in the spinal cord and brain. Voluntary functions will be carried out through voluntary nerves. That means nerves which are supplying to voluntary organs. Involuntary functions are carried on by involuntary nerves. So voluntary nervous system is referred to as somatic nervous system. Somatic means of the body. Soma means cell. Somatic is of the body. Automatic functions or involuntary functions are regulated by autonomic nervous system. Autonomic is automatic. Alright, autonomic is automatic. Automatic nervous system or autonomic nervous system is dealing with all the organs, internal organs of the body. So in everything, the function has to be increased or decreased. Both should be done. If you look at heart rate should be increased or decreased. If the heart rate is low, it has to be increased. At resting stage, it has to be at one level. If you start walking, brisk walking, or you start running, heart rate should increase. And after you stop running and you sit down, heart rate should decrease. It should all happen automatically. You should not turn on switches. So autonomic nervous system should have two components. Yes or no? In the design wise, you need to have two components. That which will stimulate, that which will rest. The nervous system, autonomic nervous system, which will cause stimulation of function is sympathetic nervous system. That which will cause normalization of function, bringing it to baseline, is parasympathetic nervous system. Is being done by hemoglobin. Hemoglobin brings about maximum transportation of oxygen. Carbon dioxide transportation. Carbon dioxide also can bind to hemoglobin But carbon dioxide transportation by attachment to hemoglobin is lesser. Carbon dioxide can combine with the water present in plasma and become what? It can become bicarbonates. It can become bicarbonates. And the major transportation of carbon dioxide is in the form of bicarbonates. Alright, major transportation of carbon dioxide is in the form of bicarbonates. So, dissolved oxygen, dissolved carbon dioxide as in the form of bicarbonate, sodium bicarbonate and potassium bicarbonate. There is sodium chloride, sodium and potassium ions are present in the blood. So, it combines with it, sodium bicarbonate, potassium bicarbonate. Then it breaks down when it comes to the level of the cell. Alright. There is one special mechanism related to carbon dioxide transportation that happens in the RBCs. What is that? Hydrogen ions are produced. Too much of carbon dioxide can lead to acidity, metabolic acidosis. Metabolic acidosis. How? There is one special mechanism associated with RBC related to carbon dioxide transportation. I will give you 1 minute to check and tell. Give me the name. Let us see how fast you can browse. Quickly run through the textbook and browse it. Only look at carbon dioxide transportation and tell me what is the mechanism associated with carbon dioxide transport. Something special related to carbon dioxide transport. I can't hear you. Come on, quickly. Huh? What? Chloride shift, yes. Chloride shift. There is another name for it. Hamburger phenomenon. Chloride shift. What is this? Chloride shift. What is this chloride shift? See, carbon dioxide combines with water. There is sodium chloride, potassium chloride, all of this present in the plasma. Chloride shift is happening inside RBCs. It is between the RBC and plasma. Not going into too much detail. Forget about where things go. Alright. Dissolved carbon dioxide as bicarbonate, sodium bicarbonate or potassium bicarbonate is not sufficient. It is not enough to transport carbon dioxide. So there is a special mechanism that has evolved in the blood for transporting carbon dioxide. This you need to understand why it is important to keep carbon dioxide balance proper in the body. If there is too much of carbon dioxide, that leads to metabolic acidosis. How it leads to metabolic acidosis? We will see. There are two carbon based gases that can cause damage to our body. Too much of carbon dioxide can cause problem. And there is one more carbon based gas which can cause functional anemia. Carbon monoxide. Carbon monoxide is like a possessive child or a possessive partner. Once it catches hold of RBC, hemoglobin, it will refuse to leave. It will refuse to live. It is like truly manifesting until death does us apart. I will not leave you. I will not let you take up oxygen. I will hold on to you. Until death of that RBC, hemoglobin is gone forever. It will never be available for transporting oxygen. Alright? Social interactions, relationships should be like hemoglobin and oxygen, not hemoglobin and carbon monoxide. Hemoglobin and carbon monoxide kind of relationships are toxic. Hemoglobin and oxygen kind of relationships is, you have your work, I have my work, we have our work. So clearly having a life. Now hemoglobin also can have its own life. It can transport carbon dioxide, it can be useful for the body, it can do some meaningful work. Carbon monoxide, what will tell? I don't care what you will do. You have to just be with me, nothing else. Nothing else is important. Don't be carbon monoxide. Alright, okay. This is RBC, outside is plasma. Alright, RBC and plasma. Carbon dioxide combines with water. What does it become? Carbonic acid. Carbon dioxide combines with water and it becomes carbonic acid, H2CO3. Now this becomes NaHCO3, sodium bicarbonate. Same can happen with potassium chloride also. Sodium bicarbonate plus chloride plus hydrogen. Alright, hydrogen ion. Where is this happening? This is not happening in the plasma. This happens in the plasma. The same reactions. The same reaction. Inside RBC also there is water, no? This reaction happens inside RBC. This reaction happens inside RBC. Now H plus hydrogen ion and chloride ion chloride ion combine to form HCl. It can combine to form HCl. So chloride shift happens. To prevent that, chloride goes out. Chloride shift happens and the reverse of that happens in the lungs. When it comes to the lungs, the reverse of it happens, chloride shift. So this is a mechanism of ensuring that a large amount of carbon dioxide can be transported. Carbon dioxide can be transported efficiently. There is an enzyme which will make this possible. You cannot break this. This is not possible in the plasma. It is possible only in the RBC. What is the enzyme? Carbonic anhydrase. Carbonic anhydrase is the enzyme which can break down carbonic acid into which can make this, which can produce bicarbonates and help in the transportation of carbon dioxide. Alright. So this is an important mechanism. We will elaborate this a little further. When we get a question related to chloride shift, we will go more deeper into it. So 3 mechanisms of transportation for carbon dioxide. One, as attached to hemoglobin. What do you call it? When oxygen attaches to hemoglobin, hemoglobin is called oxyhemoglobin. When carbon dioxide attaches to hemoglobin, hemoglobin is called carboxyhemoglobin, is it? Carbaminohemoglobin. When hemoglobin attaches to, when carbon monoxide attaches to hemoglobin, it is called carboxyhemoglobin. Carboxyhemoglobin is toxic. Not toxic, it is harmful to the hemoglobin. Not available. Alright. Why carbaminohemoglobin? Why carbaminohemoglobin? Why carbon dioxide? Where did this amino come from? Oxy understood, oxygen attaching to hemoglobin, oxyhemoglobin. Carbon monoxide. There is carbon also, there is oxygen also. Monooxygen. Correct? So you can refer to it as carboxy. There is carbon and oxygen in that thing that is getting bound to the hemoglobin. Carboxyhemoglobin. Carbon dioxide. Carbon is there, oxygen is there. Where did amino come from? Carbaminohemoglobin. How? of globin. Correct. Hemoglobin has heme and globin. Globin is a protein chain. How many globin chains are there in hemoglobin? 4. Heme core and 4 chains of globin. Every protein chain, every amino acid has an amino group and a carboxy group. That is why it is called amino acid, no? There is an NH3 group, amino group, and there is a COOH group. That is why it is amino acid. When you join amino acids together to form a protein, the protein also will have one terminal called amino terminal, where the end is having an amino group. Another terminal is called carboxy terminal. Carbon dioxide binds to the amino terminal of the globin chain. So carbon dioxide is binding to the amino terminal of the globin chain of hemoglobin. So this association is referred to as carb-amino hemoglobin. Is that clear? So 3 modes of transportation for carbon dioxide. Number 1 as carb-amino hemoglobin. Second as carbonic acid dissolved in the plasma. Number 3 as bicarbonates. Bicarbonates can be sodium bicarbonate or potassium bicarbonate. Of the 3, which is the predominant one? The predominant mode of transportation of carbon dioxide is in the form of bicarbonates. Alright, too much of carbon dioxide will lead to production of hydrogen ions, and also it can lead to production of more and more carbonic acid. That leads to acidosis. Hydrogen ion accumulation, hydrogen ion can combine with chloride ion. They combine and form weak hydrochloric acid. When it is released, it combines to form weak hydrochloric acid. Now this hydrochloric acid can lead to increased acidity. That is why keeping a balance, keeping a check on the carbon dioxide levels, making your lungs capable of proper ventilation, trying to harness as much oxygen as possible from the atmospheric air, all of that is important. Alright. Why during mountain climbing, when you are going on a mountain expedition, you are given time to acclimatize. Why acclimatization? Acclimatization is to allow the body to get used to the low levels of oxygen available. Given some time, the body will adjust to harness maximum oxygen possible from the available oxygen. Is it clear? Understanding? So ventilation we have done. Ventilation we have seen the design and the function, how it works. The design is this. The design we have the respiratory passage, respiratory network, respiratory tree, lungs, then the rib cage. How the movement of the lungs is made possible, that also we saw, because of the rib cage being attached to the lungs by the medium of pleural membrane. How this works, you can also experiment and see. Take two glass slides, place it one over the other. Without touching the lower glass slide, if you hold the upper glass slide and lift it, will it come? It will come. You can separate them. It will come off. But you add 2 drops of water on the slide and then place the second slide on top of it. So that between the 2 glass slides you have a film of water. Then you hold the top slide and lift it. Both of them will come. What is this property of water? Water in between 2 surfaces creates a surface tension that will hold this. Water has some special properties, no? It can create space between the space. It's like a vacuum space. No, there is no air there to separate. The water is holding onto it. And the property of addition and cohesion of water will keep the water film intact. The water film will remain intact. It will not break. So it can hold the lower surface also. That is how the pleural membrane functions. See how beautifully it is designed. Just 2 layers of covering and have fluid in between. You are bringing about this ventilation. When you breathe deep, the lungs expand. When you exhale deeper, the lungs contract. All of that is being made possible by the medium of this membrane. Now, there is a stab injury, somebody stabs. The knife goes into the lungs. You see it. You want to help. You say, I am a medical student, I will help. You will jump into the scene. Now, as a first aid, do you want to let that knife be there or do you want to take it out? You will take it out? You want it to be there? Not moving that knife is better because the knife has gone in, there is a puncture, no doubt. But because of that puncture, around the knife there is edema formed. Edema is accumulation of fluid which is creating tension. So whatever vessels have been cut because of the puncture, they are being sealed temporarily by the fluid pressure that is created around the knife. And this puncture also has punctured the punctured the pleura. Now this knife is keeping the pleura sealed. The knife is keeping the pleura sealed. If you pull out the knife, there will be space, there will be gap, there will be a hole, puncture there. And this puncture will make air go into the pleural space. If air enters the space between the two membranes, what will happen? There will be a disconnect between the two pleural membranes. If there is disconnect between the two pleural membranes, the efficiency of expansion of the lungs will become lesser. It can even move to the extent of complete disconnect between the two layers of the pleural membrane because of air infusion. One thing, when you pull it, the pleural fluid can leak out. Pleural fluid leaks out, air fills in between the two space, then the movement of the thorax will not be transferred to the lungs. This will lead to collapse of the lungs. This will lead to lung collapse. Lung collapse doesn't mean that it will become flat. Lung collapse means that it is not able to expand. That particular lung will go into failure. So what you need to do? Let it be. Take the person to the hospital. Secure it, stabilize it, so that during transit it doesn't keep moving and poking him everywhere inside. Alright. So go to the hospital, then do what you are supposed to do. Alright. So transportation we have done, partial pressure gradient we have done, internal respiration happens in 3 stages. Internal respiration is utilizing oxygen to break down glucose and produce high energy compounds which will eventually get translated into, which will eventually get transformed into ATP. That's all. There are 3 steps in that. What are the 3 steps in this internal respiration process? Glycolysis, Krebs cycle, and oxidative phosphorylation or the electron transport chain. We cannot consider all 3 to be respiration process. Glycolysis and Krebs cycle are predominantly glucose breakdown pathways. They are glucose breakdown pathways. Which of these two is oxygen dependent? Glycolysis and Krebs cycle, which of these two is oxygen dependent? Oxygen is required for which of these two? Krebs cycle. Krebs cycle requires oxygen. If there is no oxygen, Krebs cycle will not happen. Which of these two can happen without oxygen also? Glycolysis can happen without oxygen also. So without oxygen, glycolysis can happen. And what is the product of glycolysis? What is the end product of glycolysis? Pyruvic acid. Glucose becomes pyruvic acid. For production of pyruvic acid from glucose does not require oxygen. But if pyruvic acid has to go into Krebs cycle requires oxygen at various stages. So if there is no oxygen, pyruvic acid cannot go into Krebs cycle. What pathway does it choose? It will choose to go into lactic acid metabolism. It goes into lactic acid metabolism, pyruvic acid will get converted into lactic acid. In this process also energy is produced, but very little amount of energy is produced. Correct? How much is produced? 2 ATP is used and 1 NADPH is produced. So net production of ATP From pyruvic acid to this thing, lactic acid is 1 per pyruvic acid. 2 pyruvic acid is produced from 1 glucose. So from 1 glucose, if it goes through anaerobic respiration pathway, you get 2 ATPs. But if it goes through Krebs cycle, each pyruvic acid will produce what? 6 NADPH, 1 FADH2 and 1 GTP. 6 NADPH, 1 FADH2 and not 6, totally 236. Six NADPH only, no? 6 or 4. Anyways, I forgot the steps. How many NADPH? Totally, this pathway will give us 38 ATPs when it goes into, when the NADPH, FADH2 goes into oxidative phosphorylation or the electron transport chain. Correct? Electron transport chain also, 2 things you have to remember. Where do these, okay, during the electron transport chain, NADPH will give rise to the production of 3 ATP. The energy stored in NADPH will give rise to 3 ATPs. The energy stored in FADH2 will give rise to 2 ATPs. And oxygen dependency is there at a particular step. These 3 you have to figure out. Why NADPH is giving rise to 3 ATPs, FADH2 is giving rise to 2 ATPs. And why will we die if there is no oxygen? Why will this shut down if there is no oxygen? Where is the energy dependency in electron transport chain? I want you to go through electron transport chain of respiration and find out answers to this question. Why NADPH is equivalent to 3 ATP? Why FADH2 is equivalent to 2 ATP? And where is the oxygen dependency? Where is the oxygen dependency? Why will we die if there is no oxygen? And also one more question you have to think is, okay, I should have told that question not related to this topic. Then you should have linked it to this topic. But now because I am raising that question when I am talking oxidative phosphorylation, you know that it is related to oxidative phosphorylation. Anyways, it's okay. Half of the problem solved. Have you noticed in movies or in some other media, when you see somebody gets caught, a terrorist gets caught, he doesn't want to go through the interrogation of the police. He will have something in his neck, some dollar, some small case he will have, he'll bite into it and immediately he collapses and dies. What did he bite into? And why did he die? What did he bite into which gave instant death? Huh? Cyanide. Probably he would be having some cyanide loaded into that, and he bites into it, cyanide goes into his body and he collapses dead. Why? Why does cyanide kill? What happens when a person bites into cyanide? Why is he dying? What is it doing? So 3 questions to answer. NADPH is equal to 3 ATP, FADH2 is equal to 2 ATP. Why? Second, what is the need for oxygen? Why is it that we will not be able to survive without oxygen? You have to explain it on a molecular level. You have to tell this is why oxygen is required, otherwise we will die. Number 3, how does cyanide kill? Alright. All 3 the first 2 can be answered with your NCERT. The third one you will not be able to answer with NCERT. Think and try to find out. At least come with the logic, what it might be doing. Alright. Done. Respiration, we have completed all the 4 stages. Purpose, design and action. So 4 steps in respiration. What are the 4 steps in respiration? 3 are preparatory steps and 1 is actually respiration. So if we have to make it into 3 steps, we will call something as ventilation in school textbooks. In lower classes, it is referred to as external respiration. You might have studied ventilation as external respiration, which is not a good way to represent it. You should call it ventilation only. There is ventilation, perfusion, transportation, respiration or cellular respiration. 4 steps. Alright? Okay. Done? Any questions? Any questions? Respiration? Where are we on time? Oh, okay. No questions? All right. Quickly we will run through the same PDA for nervous system and endocrine system. All right. Purpose of nervous system. Purpose of nervous system. Why do you need nervous system? There are so many activities being carried out in the body. The body needs to function like one unit. So nervous system is required for control and coordination of all the activities that happen in the body. That is the name of the chapter also, no? The name of the chapter is control and coordination. What do you need to control and what is it that you need to bring coordination with? Coordination between. Control and coordination. Tell me what all needs to be controlled in the body. I'll make it simple. The body has functions related to keeping this body alive. Correct? Can I call those automatic functions? What are the automatic functions? Respiration, circulation, all the internal organ functions. Then is digestion also an automatic process? Eating is voluntary. Digestion is automatic. So there are automatic functions and there are voluntary functions. Automatic functions should go on continuously without you having to do anything about it. So automatic functions need to be controlled, managed. And control, rather than control, I would say managed. Why managed? Increasing the function or decreasing the function should be based on the needs. How do we know what is the need? We have to create a mechanism of identifying need. What is the need? Alright, when to increase blood supply to the muscles, when to increase blood supply to the digestive tract. So identify need. To increase survival, to increase the chances of survival, identifying the threat is important. We have to identify where is the danger, when is the danger, right?